This is section 4.4, and I'm going to say using congruent triangles. So when we talked about, we started chapter 4 talking about polygons and how we figure out that polygons are congruent. And we said that for polygons, we had to, we had to match up all the corresponding angles and all the corresponding sides. That's how we showed that they were congruent. And with triangles, we came up with a few shortcuts that let us show that triangles are congruent. Angle, side, angle, side, 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 and angle, angle, side are the ones we've talked about so far. What we want to do today is when we know that polygons are congruent, when we know that triangles are congruent, then we are guaranteed that all the matching parts are congruent. So what we want to do today is use congruent triangles, show that the triangles are congruent in order to prove that, in order to be sure that some particular matching parts are congruent. So that's what we're interested in today, is the parts of the triangle. So what we're going to do is we're going to say that this thing that I wrote on the board, we're going to say that corresponding parts of congruent triangles are congruent. So if we can show that the triangles are congruent, then we know that all the matching parts are congruent. When we use these shortcuts, angle, side, 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 we're only showing that some of the parts are congruent, and that guarantees us that the triangles are congruent. What we're doing with this is we're saying that if we know the triangles are congruent, then all the matching parts, all the corresponding parts have to be congruent. And what I wrote on the board was kind of an acronym. So we say that CPCTC. Corresponding parts of congruent triangles are congruent. We use that to shorten it so we don't have to write this. So the idea with CPCTC is we show that triangles are congruent in order to get to the parts that we want to show that match up, that we want to show that those are congruent. So that's what the whole point of this section of the chapter is about, is one, showing the triangles are congruent, and then using CPCTC to pick out particular parts that we want to show that are congruent. So what I'm going to do is just go through a couple of proofs using CPCTC to show how we use it to match up parts of congruent triangles. So here's our example. I'm going to draw a picture here. Let's do that in black. And I'm going to call this, we'll label this M, N, O, P, and Q. And we're given that segment MP and segment NQ bisect each other at point O. And we want to use that to prove that segment MN is congruent to segment PQ. So our plan here, what we're trying to do, what I want to try to do is show that triangle MNO is congruent to triangle PQO. If I can show that those two triangles are congruent, that would guarantee me that these corresponding parts, segment MN and segment PQ, are congruent. We're going to show that those triangles are congruent, and then we're going to use CPCTC. Let's start by marking up what we already know about the triangle by labeling our triangle. So first off, it tells us that MP and NQ bisect each other at O. What does bisect mean? What is it telling us? They cut each other in half. So bisect means they cut each other in half at point O. So point O is the middle of each of the segments. So what can we say about segment MO and segment OP? This segment and this segment. If point O is in the middle, then they have to be, each part cuts it in half, each part has to be congruent. So this has to be congruent to that. And we'll start writing our proof based on what we figured out here in just a second. It says that NQ is bisected at point O also. So what do we know about segment NO and segment OQ? They have to be congruent also. Point O cuts that segment in half. Well, now we've marked our triangle. We're almost there. What other piece of information do we know from this figure that we could use to prove that the triangles are congruent? We have two sides. Do we know anything about any of the angles? What is it, Lydia? So we have this, I'll mark that in blue here. We have this angle and that angle. What do we know about those two angles? They are congruent. What do we call those two kinds of angles? That kind of angle. When they're across the X from each other? Vertical, very nice. Vertical angles. So now we're almost set. So looking at this diagram, how would we say that those two triangles are congruent? What theorem or postulate? Side angle side. We have side angle side. So basically we figured out how we can do our proof. So here's our statement and our reason. Once we know that the triangles are congruent, that means that all the matching parts have to be congruent. So I'll start with the given. So we're going to say MP and NQ bisect each other at O, and a reason that's given to us. Well, the first thing that we figured out is that segment MO is congruent to segment OP, and we figured out that segment NO is congruent to segment OQ. What would we say our reason is for that? What did we say bisect meant? Cut it in half? Well, isn't this saying that they're cut in half? So this is the definition of bisect. It means it cuts it into two equal pieces. So this is the definition of bisect. then we figured out, looking at the diagram, and we need to write out, here we can't just call it angle O because there are two angles there. We're going to say angle MON is congruent to angle POQ. And what was our reason there? What kind of angles were they? Vertical. So those are vertical angles. Now we can say that the triangles are congruent. Triangle and up here I wrote NNO. This should be MNO. Triangle MNO is congruent to triangle PQO. And what was our reason there? What kind of triangles do we have here? Side angle side. We're going to say SAS. And now we know that the triangles are congruent. We can say that these matching parts, segment MN, is congruent to segment PQ. And our reason for that is CPCTC. Corresponding parts of congruent triangles are congruent. So we showed that triangles are congruent. That guarantees us that all the matching parts are congruent. Questions there? All right, I want to look at one more example using CPCTC, and then we will be done. So here's our picture for this one. And we'll call this our SUT. And we're given that segment RS is congruent to segment UT. So let's mark that. And we're also given that segment RT is congruent to segment SU. So we'll mark that. Now we want to prove that angle T is congruent to angle S. So our plan is the same plan that we had on the last one. We're trying to prove that these parts of the triangle are congruent, so we need to show that the triangles are congruent first. So our plan. We want to show that triangle RTU, I'm going to call it RUT, is congruent to triangle URS. And then use CPCTC to show that the angles are congruent. Well, this proof is almost done for us, isn't it? What other piece of information would we need to know that those two triangles are congruent? So we're looking at this triangle, and we're looking at this triangle. What's there for us to use to show that those two triangles are congruent?
Side, because triangles share that symbol.
We can use side, side, side because the two triangles share this middle piece. So I can mark that congruent. So they share this piece where I have both red and the green highlighted. So we can use side, side, side to show that the triangles are congruent. So our proof is done. We only had to figure out one thing here. So our statement, we'll write our proof. And our reason over here, we'll write our givens. We skipped that. We've been skipping that on a few of our proofs, so we'll write them out this time. Segment RT is segment RS congruent to segment UT. Segment RT congruent to segment SU. And the reason there is that's given to us. And Sam says that segment RU is congruent to segment RU. Do you remember what that reason is called? When something's congruent to itself. Not transitive, it's related to transitive. Reflexive. A couple of people said it, reflexive. So that's a reflexive property. Now we can say our triangles are congruent. Triangle RUT is congruent to triangle URS. And we said our reason for that was, what do we have? What kind of triangles do we have here? Well, what parts do we have that are congruent? Side, side, side. We have three sides. Side, side, side. And since the triangles are congruent, all the matching parts have to be congruent. So angle T has to be congruent to angle S by CPCTC. Triangles are congruent, so the matching parts have to be congruent. Matching, corresponding means the same thing. Questions there? So one clue, one hint that you need to use CPCTC is if it has something to do with triangles, but you're only looking to show that parts of the triangle are congruent. It's not asking you to show that the triangles are congruent, it's asking you to show that parts of the triangles are congruent. So that would be a clue that you need to use CPCTC. We're trying to match up parts of triangles. So questions there? All right, next time we're going to talk about some special kinds of triangles, some things that we can figure out about certain kinds of triangles, isosceles triangles and equilateral triangles, and some special things that happen with those triangles. All right, let me stop this. We will